So we'll start with this new topic on interrupts, exceptions, system calls, and context switching. So what we have seen so far, right, over multiple things is that you have your processor, right, and you have a reset pin, and when you give this reset pin a pulse or a specific signal, then your OS starts to boot, right. So this is where the reset is obtained, and your OS starts to move. It starts in machine mode and then goes into the supervisor mode. The OS boots up, and then after some time later it switches and creates a user process and then starts to execute the user process. So here is where you have the machine mode code. Here is where most of your OS executes in the supervisor mode, and this is where the user processes execute. Right. So typically once the OS initiates the user process and permits it to execute, it doesn't gain control unless there is an event that occurs, right? Or in other words, once the user process starts executing, the OS, which runs in supervisor mode, only executes when there is some event that occurs, right? So in other words, if I want to write this as a statement, the OS executes only when events occur. So these events can be of two types. So these could be software events or hardware events, right? Or also called like software interrupts. Or hardware interrupts. Right. So it is only when such events, either software or hardware interrupts occur, would the OS get to execute. So if I look at it in this figure, the user process continues to execute, and some point there is an interrupt, which could be either a hardware or a software interrupt, and this shifts the processor back from user mode back to the supervisor mode and permits the OS to execute. The OS services this interrupt, executes certain functions as is required for this particular interrupt, and then goes back into the user mode and lets the user mode processes continue to execute, right? And this keeps going on and continuously. So the user processes execute until there is some external event, or which is either the software interrupt or a hardware interrupt, and then the OS executes. Okay. So what are these software interrupts and hardware interrupts, right? So we've seen examples of software interrupts. Software interrupts, for example, are used in system calls. So when you do an e-call, or we have an e-call instruction, that essentially would create a software interrupt, forcing the OS to execute. Hardware interrupts, on the other hand, are triggered by external devices. So it could be, for instance, say a keyboard or a mouse click, or let's say a timer going off. So some external event outside the CPU core, the processor core, that when it occurs, then we call that as a hardware interrupt, right? So besides software and hardware interrupts, a third type of event that can occur are essentially exceptions. For example, a page fault could be an exception, or anything, say a divide by zero. So you're running a program, and let's say the program tries to divide a by 0. So this would essentially lead to an exception, forcing the OS to execute, right? So for example, this would be a divide by 0. Okay, or another one could be a illegal instruction. Right. So if the while the processor is executing, it obtains some instruction which it cannot recognize, or an opcode which it cannot recognize, that would lead to an illegal instruction exception. Okay. Okay. So how does it work? So there are a couple of things that the OS needs to know once it starts executing. So we know that after booting, after it starts the user process, the only time it executes is when one of these events occurs, right? So when an event occurs, when the OS starts, as soon as the OS starts to execute soon after the event occurs, so it needs to identify whether this event was a software interrupt, a hardware interrupt, or an exception. And once it identifies what is the cause of this event, it would need to invoke the right handler, or the right interrupt handler, or the event handler to service that particular interrupt. For example, if it is a software interrupt, for example, a system call, this needs to be recognized soon as the OS executes, and the right system call needs to be executed. In a similar way, if the interrupt has occurred, say due to key pressed on the keyboard, the processor needs to identify that this interrupt originated from the keyboard, and therefore needs to call or invoke the functions in the device driver for the keyboard to read the character that was essentially pressed, right, or read from the keyboard. Okay. So what else? Yeah. So what we essentially see now is that the events specified, the events, either software interrupt, hardware interrupt, or the exceptions, need to be serviced specifically based on which event has occurred. Needs based what interrupt has occurred, cause the interrupt. Okay. So the important thing over here is to identify what caused the interrupt. Okay. So in order to identify what caused the interrupt, the processor essentially maintains a particular register which is called the cause register. Okay. So depending on whether the interrupt occurred while the supervisor mode was executing, the processor was in the supervisor mode, the corresponding register is called the SCOS. If the interrupt or event occurred while the machine mode, while the processor was in machine mode, then the COS is called the MCOS register, right? So you would have multiple registers, either SCOS or MCOS, and the hardware, the processor, essentially fills up this register with a very specific value that would identify what caused the event, right? Whether this event was due to a software interrupt or a hardware interrupt or any of the exceptions, right? So how does this help? So what happens is that when the event occurs and there is a switch from the user mode to the supervisor mode, the the OS would read the cause register and identify the cause of the interrupt, right, or of the event, and take appropriate actions, like for instance invoking the right function, the right device driver, or the right system call accordingly. Okay. Now, in addition to this cause register, there is also a few other registers that are important. So one is the interrupt. There are two other registers which are important. One is called the interrupt pending register. And the other is called the interrupt enable register. Okay, so the interrupt enable register would have different bits through which a programmer could either set 0 or 1 to enable or to disable or enable interrupts. While interrupt pending register essentially is set by the hardware, like the processor core, to essentially tell the operating system whether there is an interrupt that needs to be serviced or not. So, for example, if there is a 1 set in the interrupt pending register, it would essentially indicate that there is an interrupt that needs to be serviced. Okay. So, given this brief introduction, we will now look into it more in detail, specifically focusing on the interrupt handling in RISC-V processors, right? So again, as just to recollect, the operating systems are essentially event driven. So after it boots up, um, the only time the OS executes is when an event occurred, right? So so typically user processes execute in the user mode, and a user process will continue to execute until an event occurs, right? Now the event would essentially switch the processor from the user mode to the supervisor mode and then cause the operating system to execute. The OS would service this particular event. It could be either a hardware event or a interrupt or a software interrupt like a system call or an exception, and then it would essentially return back, cause the processor to go back to the user mode, right? Now when the user mode when the processor switches back to user mode, either you would have the same process, that is user process 1 executing, or the scheduler may essentially pick another process, for example user process 2, and to essentially execute, right? So over a period of time, the processor switches between user mode and supervisor mode in order to service these very specific events. The reason why we essentially design the operating system in this way, where it is event driven, is the fact that the OS is considered as the privileged software. So it manages the entire software stack. It creates applications, it provides memory for the applications and so on, and yeah, and therefore is highly trusted. So the OS cannot essentially trust user processes, right? And therefore it needs to be isolated from all the user processes, and therefore it is run in the supervisor mode. So by having the an event driven design, the OS could essentially guarantee fairness to all the users. So if you have one particular process which is, say, executing an infinite loop, the OS could essentially interfere, it could essentially halt or kill that particular process, and then permit the resources like the CPU to be accessed by other processes, right? So one process cannot essentially hog the CPU time. With the help of these interrupts, the OS would be able to achieve fairness among all the user processes. Okay. Now, very broadly, we've discussed this, that events are of two types. It could be either interrupts or it could be exceptions, right? So interrupts are either hardware interrupts or they are software interrupts like system calls. Hardware interrupts, on the other hand, are like interrupts originating from external devices like keyboards, mouse, network cards, hard disks, and so on. Exceptions, on the other hand, is essentially a violation or some problem that occurred while the program is executing. Like the divide by zero is an example of an exception, um, and an illegal instruction was another exception that can occur. So, when any of these, whether a hardware interrupt, software interrupt, or an exception occurs, it forces the operating system to essentially execute and service the corresponding event.